Hi, and welcome to CoachFactory.net. This is Avod Muhammad, instructor for CCNA, CCNP, and CCI. Today we'll be discussing about IP version 4 addressing. We'll be discussing what is an IP address, why do we need it to assign it to a computer, and what are the different categories we have in IP addresses, like public and private, what is the difference between them, where we will use public IP addresses, where we will use private IP addresses, and why, and what are the different ranges in public and private IP addresses. How do you write IP address, it is in how many bits, and in which format do you write it. So these are the basic stuff we are going to discuss in today's session. So IP addressing. What is an IP address? IP address is a logical address which works on network layer in OSI model layer 3. We need this IP address to assign it to the computer so that every computer has a unique IP address to exchange the data between them. For example, if we want to send a letter to somebody, we need to have address from who wants to send this address to whom we want to deliver it. We'll be writing our name and our house number, then we'll be writing to whom we want to deliver it, that person's name and his house numbers. So these are the address we require. This is mandatory so that the postman can able to deliver that letter to the specific address which we define over there. In the same way, if a computer wants to send some data to another computer, that computer need to have an IP address so that we can able to send the data to that particular destination address. So IP address is a logical address which will be assigned to the computer so that they can able to exchange the data between each other. Apart from IP address, a computer also has something known as MAC address. That MAC address is known as physical address, and IP address is known as what? Logical address. So the main difference between the IP address and MAC address is IP address is the logical address and MAC address is the physical address. Just like when you want to send a letter to somebody, what you will be doing? You will be writing from. You will write your name and your house number. Then you will be writing to, name of the person and the house number, right? So these house number is just like the MAC address, and name is just like what? Name is like the IP address, whereas the house number is just like the MAC address of the computer. So as we required both name as well as house number to deliver a letter to somebody, the same way a computer requires these two things, IP as well as MAC address. This is the physical address as well as IP we required to a computer. This is known as what? Logical address. So IP version 4 address is in 32 bits, and how do we write it? We will write it in dotted and decimal format. So how the IP version 4 address is in 32 bits? The IP version 4 address has been divided into 4 octets. There are 4 octets in IP version 4 address, and each octet contains 8 bits. So this is 1 octet, second, third, and 4. So every octet contains what? 8 bits. This is binary numbers, zeros. These are known as what? Bits. So every bit has a predefined value, 1 to 128. So this is how we have 4 octets in IP version 4 address, and each octet has 8 bits, so 8 into 4 equals to 32 bits. So this is how our IP version 4 address is in 32 bits. And how do we write it? We write it in the dotted and decimal format. For example, this is my IP version 4 address, and this is what 10111 is a decimal number. This is called a decimal number, and we separated these decimal numbers using dots. So how we write it? We write it in dotted and decimal format. So there are 2 types of IP addresses we have. One is known as public IP address, another known as private IP address. So public IP addresses are the globally unique addresses. Means if I purchase this public IP address, then in the entire world nobody will have the same public IP address, because it will be sold out globally. That's why it is known as globally unique address. And the advantage of purchasing these public IP addresses are we can able to access the internet. If you don't have public IP address assigned to your device, you cannot able to access the internet. And we need to purchase this public IP address from the internet service provider. And from where this internet service provider will purchase IP addresses, they will purchase the IP addresses from IANA. Now what is IANA? IANA stands for Internet Assigned Number Authority. Internet Assigned Number Authority, which is located in America, and it's a non-profit organization which oversees the global IP addresses allocation, as well as something known as autonomous system number allocation. So all the regional ISP is going to get these public IP addresses from where? From the organization called IANA. So the private IP addresses known as locally unique addresses. Locally unique means what? Let's say this is my organization, and I have few computers in my organization. I need to assign private IP address to these computers. Let's say I assign this IP address 10.1.1.1. To this computer I cannot assign the same IP address. I need to give what? A unique private IP address. Because if this computer wants to send some file to this computer, he has to have a unique address. If I give the source address the same and destination address the same, what happens? The computer doesn't know where to send it. It will get confused. That's why every computer, whether we are assigning a private IP address or public IP address, we need to assign what? A unique IP address, so that these computers can able to identify each other and exchange the data between them. Private IP addresses are available free of cost. Means we don't need to purchase it. It's free of cost, free to use in your internal network. So generally we use these private IP addresses in our internal network. Now we have public IP address range as well as private IP address range. Now what is the difference? We already discussed what is the difference between public and private IP address. Now let's see what are the difference between these class A, class B, class C and class D addresses. Now every class has different range, different starting range and different ending range. Class A starts from 0, goes up to 127. Class B starts from 128, goes up to 191. Likewise, we go up to what? 255. So 0 is our first IP address and 255 is our last IP address. Even though we got 5 classes in public IP address, we can only use up to class C. Class D is reserved for something known as multicasting purpose. There are some protocols we have which we are going to learn in CCNA itself. These protocols going to exchange the data between them using these class D addresses, which is known as for multicasting purpose. So that's why we are not going to use the class D addresses, and class E addresses is used for research and development. So this is reserved for research and development, so we cannot use that. We can use A, B and C. These any IP address belongs to these three classes to assign it to our computers, routers and switches. But we cannot use class D and class E because they are reserved for different purposes. So if you see any IP address, how you are going to differentiate that which class this IP address belongs to? Now this one, using or seeing the first octet number, you can easily identify whether it belongs to class A, class B or class C. 10 belongs to which class? It is fall into what? 0 to 127 range. So it comes under 0 to 127 range. So it is a class A address. Now you don't need to bother about other three octet number. It could be anything between 0 to 255. It could be anything between 0 to 255. So same way, if I write 193.1.1.16, which class IP address this is? I just need to check this first octet number. Belongs to class C range, 192 to 223. So it's a class C range. So this is how you can identify or differentiate an IP address. It belongs to which class. Private IP addresses range, we got the entire 10 block for the private use, and we got 172.16.0.0 up to 172.31.255.255 addresses reserved for private use, and we got 192.168.0.0 up to 192.168.255.255. So how do we write an IP address? We'll write like this: 10.0.0.0. This is not an IP address. This is something known as what? A network. How can I say that this is not an IP address? This is a network, because an IP address cannot be zeros. An IP address cannot be 3 zeros. It has to be some decimal values, decimal numbers over here. For example, 10.0.0.1. This is an IP address. So maximum one IP address can have 2 zeros, but it cannot have 3 zeros. A network can have 3 zeros, 2 zeros or 1 zero. So what is the major difference between the network and an IP address? This is, I said, this is an IP address. Also some people called it as host. This is a network. A network can give you many IP addresses, but a single IP address cannot give you any other IP address. It's a single specific IP address. For example, take it network as street address. This is our street 10. And take this IP address as house numbers. This one has what? House numbers. So in a street, we may have n number of house numbers, and all those house numbers belongs to which street? Street 10. In the same way, this is the 10 network, and we can have many IP addresses, and all these IP address belongs to which address? Which network? 10 network. 10.0.0.2, 10.0.0.3. We can go up to what? Up to 255. That's the maximum we can go. We cannot go beyond 255. So all these 0 to 255 IP addresses belongs to which network? Network 10. Each class IP address has different network and host portion. Different network and host portion. So we understood what is a network and what is an IP address is. So every class has what? A different network and different host. You can see this is class A IP address which got one network and 3 hosts. N stands for network, H stands for host. And this is class B, we got 2 network and 2 host. Class C, 3 network and 1 host. So we can easily understand, okay, class A has 1 network and 3 hosts, class B has 2 network and 2 hosts. But how a router going to understand these IP address has how many network and how many hosts? There should be something which will differentiate or tells the router or computer that, okay, this IP address has 1 network and 3 hosts, or 2 network or 2 hosts. So we got something known as subnet mask. This is 255.0.0.0, known as what? Subnet mask. Now what is this subnet mask? Subnet mask is used to identify the network and the host portion of an IP address. By seeing the subnet mask, you can tell this IP address has how many network and how many host portion. So we got something known as prefix mask also. /8, whenever you write /8, /16, /24, these are what? These are known as prefix mask. Whenever you see 255.0.0.0 or 255.255.0.0.0, that is known as what? Subnet mask. Both has the same definition. Both will be used to identify the network and the host portion of an IP address. So we'll see how we will write this, why class A has /8 and class B has /16 and class C has /24. So as we discussed before that, every octet has 8 bits. So this is a network portion, right? How many bits it has? 8 bits. So 8 bits are reserved. We cannot use these 8 bits. And all these host portion is used. Means 0 up to 255 we can use it. But all the 255 bits, numbers, which belongs to the 8 bits, we cannot use that. So that's why /8 means 8 bits belongs to 10 network is in network and reserve. We cannot use that. This is my 10 network. This is my starting IP address. We can keep writing up to what? 255. Once it becomes 255, then I can write what? Up to what? 250. Once it becomes 255, then it will become 2. So it will, these are what? These are the host portions. So we can keep changing it up to 10.255.255.255. But if you notice, this network 10, we cannot change it because it is reserved. So it contains how many bits? It contains 8 bits and all the 8 bits are reserved. And how we got the subnet mask 255.0.0.0? Because we have these numbers. We got the 8 bits. We got this number 1, 2, 4, 8, 16, 32, 64 and 128. So these are the numbers we got, predefined values. When you add 1 to 128, it becomes 255. So subnet mask, how we calculate the subnet mask? Based on the bits value. And how we calculate the prefix mask? Based on how many bits are in the network portion. The same way, class B has 2 network portion, so /16, 8 are reserved. 16 bits are reserved, class B, and 255. So these are the bits value we calculated, 1 to 128, that's why 255. So this is 0 to 255, all these numbers are reserved, we cannot use that. And it is 00 means we can use up to 255. And in class C, we got 3 network portion. That's why it is /24 and 255.255.0. This is the subnet mask. So we are done with the today's session. I thank you for watching it.